Welcome to ACE Online and ACE Preparation League, my dear friends. As a part of SSC CGL preparation, today we are going with one of the important topic in quantitative aptitude, number systems, my dear friends. As part of SSC CGL concern, in this number systems topic, which concepts we have to focus? There are many concepts actually under this number systems topic. Yeah, we have basic definitions and recurring decimal conversion to fraction, units place or last digit. We can also call that as a cyclicity concept, reminders concept, number of factors or divisors concept, divisibility, highest power or factorial, successive divisors and base systems. These are the different concepts in number system topic. But as per SSC JE, SSC CGL concern, so guys, these 5 concepts you need to focus more for SSC CGL concern. Under this topic here, there are many concepts we have, but more questions are focused as per previous year papers on these 5 concepts, my dear friends. We can say yes, recurring decimal to fraction or units place or last digit, reminders concept, number of factors or divisors, divisibility, you need to focus a lot. Right. Now let's start with the first one, my dear friends. Basic definitions today we're not focusing, we'll just start with the recurring decimal to fraction conversion. Yes, see the first one, my dear friends, recurring decimal to fraction conversion. What is this recurring decimal or repeating decimal? We can also call, see, 2 by 3, we can write it like, okay, 0.666, okay, this is repeating, right? Okay, we are approximating this as 0.67 in general, but 0.666, this is 6 is repeating. Okay, so we can make it like 0.6 bar here. Okay, as this 6 is repeating, we can take it like 0.6 bar. This is what the one of the example for recurring decimal. Okay, and 1 by 9 is nothing but 0.11111 so on. It's nothing but 0.1 bar we can call. And 1 by 99, this is very important actually. 1 by 9, 1 by 99 is very important for us in today's discussion. This is 0.01, 0101 like that it will repeat, my dear friends. Yeah, we can write this as 0.01 bar. This is recurring. 1 by 99 is 0.01010101 like that. We can put it like 0.01 bar. And similarly, 1 by 999, we can write it like 0.001, 001, 001 so on. So we can write this as 0.0001, okay, bar for this as it is repeated, 0.001 is repeating, okay, we can write this as 0.001 bar, my dear friends. This is important for us today to convert this recurring decimal to fraction actually. Suppose, my dear friends, in question if they given 0.5 bar, for example, 0.5 bar, you know 1 by 9 is nothing but 0.1 bar, right? So 0.1111 so on, 1 by 9, 5 by 0, see now 0.55 so on means we can write this as 5 by 9, my dear friends. See this is important for us. The discussion already you know 1 by 9 is 0.111 so on, it's recurring. Now 0.5 bar, 0.555 so on can be written as 5 by 9. And similarly 0.27 bar can be written as 27 by 99. How, sir? This is 0.2727272727. If we take 27 common, this is become 0.01010101. If I take this 27 common, my dear friends, it is like 0.01010101 like that. We can write it like 27 by 99. Similarly, see this direct conversion, 0.235235, okay, so on, means this can be written as 0.235 bar, and we can directly convert this is 235 by 999. Okay, see this is what the reason. If we take 235 out, okay, what will happen? 0.001, 001 will come. It's nothing but 1 by 999. Got it? So guys, okay, while doing the examples for previous papers, you just see this conversions how to do. 0.5 bar can be written as 5 by 9, means 0.555 so on is 5 by 9. 0.27272727 so on is 27 by 99. 0.235235 so on is nothing but 235 by 999. Right. And one more conversion you have to focus before going for the example. Yeah, let's see one example here, which is given in previous CGL paper. Okay, in 2017 they given this question. Okay, see this, n is given, m is given. Now see the advantage of this conversion, what you learn. So guys, here n is nothing but 0.369369 is repeating. So we can write this directly 369 by 999. We can cancel with 9 here. This is 41 times 41 by 111, right? Whereas similarly m is 0.531531 so on. We can write this as, again this is 531531 repeating. We can write this as 531 divided by 999, my dear friends. Again, if you just check it out, this is 9 triple ones and 959 times. It's 41 by triple one. This is n. M is nothing but 59 by 111, right? Now here you want to find 1 by n plus 1 by m value, my dear friends. 1 by n plus 1 by m value we have to calculate. N is 41 by 111. M is nothing but 59 by 111. You have to calculate 1 by n plus 1 by m, which is, you just observe the previous, that 111 will go to numerator now because 1 by n, 1 by m. Okay, so we can put it like, okay, 111 divided by 41 plus 111 divided by 59. If we take that 5 common, my dear, 111 common, my dear friends, see this calculation. Yeah, 111 you can take it out, and here 59 plus 41, we take LCM denominator, okay. Denominator is 41 into 59. Both prime numbers LCM will be product of that. 59 plus 41 is 100. So 11,100. Denominator 41 into 59. So 1 into 9, we have to end with 9. This is in terms of 2000. This is 40, this is around 60. 2400 something we have to get, ending with 9. 1100 should be there in the, 1100 should be there in the numerator. 11,100 should be there in the numerator. Ending with 9, we have option E. 11,100 divided by 2,419. Yeah, you can go with the option. Why you have to multiply all that? We can approximate it. I have given you clearly. This should be around 40 into 60, 2,400 nearly. Yeah, if you do exactly using that Vedic tricks also, we will get 2,419. But this is what, my dear friends, selecting the option C. The trick, what you learn, converting, okay, given decimal, that to recurring decimal to fraction is helping us here. Right. Now see the next question, my dear friends. See this question here, you have to find the value of this one in terms of recurring decimal only. 3.36, here 36 is repeating, 36 minus 2.05 is repeating, and here 1.33. So guys, what you can do, you can take that integer separately. Integers is what? 3 minus 2 plus 1, that you put separately, and take this decimal part separately. 0. That to recurring decimal 0.36 bar, okay, and minus 0.5 bar, 0.5, right, okay, 0.05, 3, okay, next one is 0.33, so 0.05 and 0.33, my dear friends. Now say this, okay, this is anyhow 4 minus 2, we got 2, and here this is directly we can do because every number here is recurring with two digits, is that 360533 33. You can do it directly. Like see 36 plus 33, 69 sir, 69 minus 5, 36 plus 33, 69, 69 minus 5, 64 sir, we can write 0.64 bar. Altogether this is 2.64. Directly we can do if every number is having recurring with 2 decimals, if it is there, okay, we can do that directly. But sir, if different combinations is there, one with 2 recurring, okay, 2 digits recurring, or 1 digit recurring, 3 digits recurring, repeating, then how to do? We'll see the next question, my dear friends. This one directly we can do, taking integer part separately and the decimal part separately, and both are, every number is having 2 digits recurring as it is, so we can do directly. Now see the next question. Yeah, my dear friends, see, very important here. This is 2 digits repeating. Here 2 digits, this is only 1 digit doing. Now what you should do, see, write that, okay, this is also previous year paper. So 0.575757 like this. When these are different things, you just try to expand that. This all not 2 digits repeat. This is 2 digits repeating. Here single digit repeating. Here also 2 digits repeating. Different combinations is there. Now what you can do directly, 0.57 bar means 0.575757, so on. What about next? Write positive terms first, negative term at the end. 0.35 bar. So 0.3555555, so on. And we have to subtract 0.4. This is 32 is repeating, 32 is repeating. So I can write 32 or 32323 like that, so on. Now guys, do up to 5 decimals. It's not required for entire. Do up to, okay, we've taken up to 6 numbers, right? Yeah, fine, let's see about that. You can map it here. Yeah, 7 plus 5, 12. You can just say this is 0.432, right? Okay, fine. Here 7 plus 5, 12, 12 minus 3. Okay, 7 plus 5, 12, 12 minus 3. We got 9. This is last one is subtraction, first 2 addition. Next, 5 plus 5, 10, 10 minus 2, we got 8. Okay, next, this is completed. This is, now we have to focus. Yeah, 12 minus 3, we got 9. Then 10 minus 2, we got 8. Then 12 minus 3, 9. Now here, 5 plus 3, 8, 8 minus 4, we got 4. See, the result is 0.498989, so on, it's keep on going. So we can write directly, 98 is repeating, so we can write this as 0.498 bar. That 9898 is repeating. So option A, my dear friends, see this one, 0.57 bar, so 57 or 57 repeated. Okay, whereas here 0.432 bar, 32 is recurring, so that's what, okay. But first I am writing positive symbol, 2 additions, then that negative number next. Okay, when you calculate, yes, we can see directly it's 0.498 bar. Clear, this is the previous year question, my dear friends, in 2019 they asked. Now see the next question. Before going for the next question, my dear friends, see how to write 0.23, where 3 is recurring, okay, 0.23 bar. So how to write this 0.23 bar in terms of fraction? This is recurring one. How to convert this into fraction we have to do? Well, we are going to learn now. See this, my dear friends, 0.23 bar. Now how to do this is, listen, we know 0.3 bar is 3 by 9, right? Okay, if it is 0.3 bar, 0.7 bar like that, but here it's not in that case. Now what I'll do, I can write this as 1 by 10, 1 by 10, and here 2.3 bar. We can write like this as 1 by 10, 2.3 bar, and this is, I can split it. See that how you can split this one. I'll give a shortcut at the end, my dear friends. See, 1 by 10, 2 plus 0.3 bar. So 2 plus 0.3 bar is nothing but 3 by 9, 1 by 3. You know 0.7 bar is 7 by 9. 0.8 dash is 8 by 9 like that. So this is 0.3 bar. So we can write this as 3 by 9, nothing but 1 by 3. Okay, so here 1 by 10, 2 into 3, 6 is 6 plus 1, 7, 7 by 3. This is 7 by 30. So how to write this 0.23 bar? Okay, in terms of fraction, this is recurring decimal only. In terms of fraction is 7 by 30. So this is taking more time for us. Yes, we'll give the alternate for that. But see, when it is 1 bar, we are dividing by 10, because I can do only when it is 0.3 bar, 0.45 recurring, 45 is recurring. For that we have a shortcut, 45 by 99 like that. Okay, so we have to make that into a single decimal here, dot 0.3 bar, 0.45 bar like that. So we should divide by 10. Sometimes we should divide by 100, depends on the question. Now see the shortcut, my dear friends. Write 23 minus, see this recurring is there only for 3, right? Okay, 2 is not having recurring, so subtract 2 divided by, for how many terms that recurring is there is for only one term, 9. For one term recurring is not that, for that 10. See the shortcut, I repeat, 23, I will give one more example also, 23 minus, okay, this recurring is not there for 2, do minus 2 divided by, recurring is there for one number 9, for one number recurring is not that, 10 for that. So what we will get, 21 by 90, 7, yeah, 3 7 times, 3 30 times, we got 7 by 30, same thing, whatever you have here, 7 by 30, same 7 by 30 we got here. Now one example for you. So guys, if it is 3.7 bar means this is easy, 0.037. 3.7 means directly we can do, there is no much update for you, you are fine. If it is 0.37 bar. So guys, for this one, let's try to give the response. I'll check in your live chat. What's your answer, my dear friends, here? 0.37 bar. Yes? Answer? Waiting for your answers, my dear friends. See this one, what you can do, this is 37, okay, minus, recurring is not there for 3, so minus 3 divided by, okay, for one number recurring is there 9, for one number recurring is not there 10. So we got it, this is 34 by 90, and cancelling the common terms, so we can put it like 17 by 45. See this one, my dear friends, how to do 0.37 bar, this is how you can map it, 17 by 45, my dear friends. This is 0.23 bar, this is 0.37 bar, we got 17 by 45. Clear? Fine. And suppose, sir, if there is two decimals, okay, two numbers are recurring, for example, if it is 0.5, 76 is repeating, my dear friends, 0.5, this 0.5 is not repeating, 76 is repeating, then what you should do, take 576, which is not recurring here 5, subtract 5, divided by, see this 576, entire, 5 is not repeating, okay, so subtract that 5, as we have two numbers recurring, we have 99 now, for one number it's not recurring, into 10. So this is how you should convert, okay, this numbers. Previously it's all direct one, easy, 0.6 bar, 0.76 bar, but now 0.576 bar, 76 is repeating, 5 is not repeating. Sorry guys, 76 is repeating, 5 is not repeating. So 576 minus 5 divided by, because of 76 we have 99, 5 is not repeating for that 10. Clear? This is how you should convert recurring decimal into fraction, my dear friends. See a few more examples how you can utilize this trick. Now see this question, my dear friends. 22.4 bar, okay, 11.567 bar, 33.59 bar. Here, first take integers separately. This is also previous year question, right? See, take integers separately, my dear friends. 22, 11, 33. I think one among this sign is went wrong. I think this is plus for you. Yeah, typo error. Let us ignore it. So 22 plus 11 minus 33. That integer part you can just put it out. Yeah, that's anyhow becomes 0. Now focus on that decimal part. 0.4, 4 is recurring there. Then 0.567, 67 is repeating. Then 0.59, 9 is repeating, my dear friends. See, when this type of number 0.4, 4 is repeating, 5 not repeating, 6, 7 and 5, 9. You can use the previous trick, converting into divided by 9, 4 by 9. This is 567 minus 5 by 9, 99 into 10. That trick you can apply. Or else the other one we discussed in the previous question, 0.444, like that we can write. 0.567 bar, so 0.567, again 67, 67 like that we can mention. Whereas next one, 0. These two are adding, last one is subtracting. 0.5, 9 is repeating. So I can write 9, 9, 9, 9 like that. Now first two we have to add, my dear friends, last one we have to subtract. Now see this, 4 plus 6, 10, 10 minus 9 we got 1. 4 plus 7, 11, 11 minus 9 we got 2. Again here 10 minus 9, 1, 11 minus 9, 2, 10 minus 9, 1. Here 9, 4 plus 9, 5, 9, 9 minus 5 we got 4. You can see, my dear friends, 0.4, 1, 2, 1, 2 is repeating, right? So what we can do, 0.4, 1, 2, 1, 2 repeating, we can write 0.4, 1, 2, but this entire expression answer is nothing but 0.4, 1, 2 is repeating, my dear friends. 1, 2, 1, 2 is repeating. We can go with option B. See this directly, we can mention that 0.4 bar as 0.444 so on, and here 0.567 bar, 6, 7 is repeating, right? Okay, and 0.59 bar, 9 is repeating. You can do adding these two and subtracting. You got 0.412, 412, my dear friends. See, 1, 2 is repeating. Clear? Okay, let's see one more question related to your previous year paper. Okay, regarding this recurring decimal conversion into fraction or recurring decimal to recurring decimal directly. Now this question you can learn something, my dear friends, as you have multiplication. Previous one, okay, sir, this is nothing new for us. We can do directly. Is recurring, we are writing directly. Addition, subtraction, we know anyhow. Yeah, we agree. But next question, what are the tricks we discussed in previous will help you now, because see, these two fine, you can subtract, but here multiplication you have to do. Now here the trick will help you, my dear friends. See, 0.39 bar and here 0.7, right? If you just recall, 0.39 bar can be written as 39, yes, minus 3 is not recurring, so minus 3 divided by, for one number recurring is there 9, for one number recurring is not there 10. Okay, 0.7 bar is, it's simple, 7 by 9. If you just see this 36 by 90 into 7 by 90 into 7 by 9, my difference, 9 ones, 9 fours, we got 28 by 90. Now listen, this is very important. Again converting the fraction back to recurring decimal I am doing. See, 28 divided by 90. What should be the recurring decimal? For what recurring decimal we will write 28 by 90 is, see, 90 is there means one digit should repeat. For one digit 10 is there means for one digit there is no recurring is there. So you just recall, check here, can we write this as 0.31 bar? Can we write this as 0.31 bar? So what will happen? 31 minus 3 is 28. 31 minus 3 is 28. See, this is very important how you are doing. Okay, this recurring decimal to fraction, again fraction to recurring decimal, then what is the use, sir? Yeah, you can change it here, 0.56, 6 recurring, so 0.723, 23 is repeating. Now here, this is 0.31. So this is now routine for you, like previous questions, 2 questions what to discuss. You can write 0.5666, here 7232323, 0.311, and that too preferably first take the 2 additions, then negative term at the end. You can do that easily. Fine, this will give option A, my dear friends, if you expand this expression. But important learning point here is converting this recurring decimal to fraction and then fraction to recurring decimal, right? See the next example, previous question given in SSC CGL, same format they given, slight change in values. Okay, this one also you can practice, and guys here you just try this one first, only this one, remaining you can do later. You will get option D, okay, on calculating all this at the end, but this one important, 0.39, 39 is recurring, so 39, it's actually 39 bar, again typo error, I hope this is 0.39 bar. Yeah, take it, it's 39 bar, 39 is recurring there, it's not 0.39, typo error, okay, consider that's 0.39, for 9 is only recurring. Now what you can do that part, 0.39, that 9 is recurring means 39 minus 3, for one digit recurring 9, other digit not recurring 10, okay. Now 0.8, 8 is recurring, so 8 by 9 directly. This is direct one, 0.8 bar means 8 by 9, 0.7 bar means 7 by 9. We discussed already in the introduction, but this is important. Now see, we got 36 divided by 90 into 8 by 9, 9 ones, 9 fours, my dear friends, we got 32 by 90. Now convert again this 32 by 90 in terms of recurring decimal. Then you can substitute that part here, remaining all can be easily done. Now see this one, my dear friends, how to convert this 32 by 90. 90 means, okay, one recurring, one normal one. One number here recurring, one is normal one without recurring. This is 35, because 35 minus 3 will give 32 for you. 35 minus 3 will give 32 for you. This is 0.35, 5 recurring. Now my dear friends, the question is simple. 0.477 is recurring for you. 0.503, 03 is recurring, and this entire next expression is simplified as 0.355 is recurring. This you can do like previous question, you can expand 4777 like that, 0.5030303 like that, whereas here 0.3555 like that you can subtract and you can finalize. That's not a big issue for you. But my dear friends, converting given decimal to fraction, fraction to decimal is important to solve this type of questions. All these are previous CGL questions, SSC CGL, okay. Now see the next one, my dear friends, units place or last digit. We can also call this a cyclicity concept as well. Cyclicity concept. So what is this units place or last digit or cyclicity? See, generally what they'll ask you, find units place. Question format will be in general, find units place in. Suppose I can ask you, okay, 123 into 52953 or maybe 957. For this big number, okay, I am asking you to find units place. To find units place, we no need to, okay, do this entire multiplication. You people know already, okay, while doing calculation, that's the trick for us we are playing. Units place here 3, units place is 7, 3 into 7 is 21, so answer definitely end with 1. If you do 123 into 52,957, my dear friends, 3 into 7 is 21, answer is ending with 1. So what is the units place here? For this answer is nothing but 1. Okay, this is a basic example how to find units place in this 123 into 529. Okay. Now see, whereas the questions in general, that's a basic question related to multiplication, but in general they may ask you a question like find units place in 430 to the power 1231, 1231, this big number 432 to the power 1231, this big number you have to find units place, my dear friends. Here first thing what you have to do, units place here is 2, we should write this as 2 power 1231. Now you should analyze 2 powers. What is the analysis for 2 powers? See, 2 power 1 is nothing but 2, 2 square is 4, 2 cube 8, 2 power 4 16, units place is 6. Units place, here our focus is on units place only, whereas 2 power 5 32, units place is 2, 2 power 6 64, units place is 4, 2 power 7 128, units place is 8, 2 power 8 256, units place is 6. By this time you can understand units place is repeating after 4 powers. You can see after 4 powers same units place is repeating. Okay, same units place is repeating after 4 powers. That is why they call this as cyclicity concept. It is cyclic. Okay, after certain time the same units place is repeating. After 4 powers same units place is repeating. Here what we should do, we should divide power with 4, because suppose I don't know 2 power 9, actually 2 power 9 is 512, units place is 2. For example, you don't know 2 power 9, we will take that power 9, divide with 4, for 2 times 8, remainder is 1. Now among 2 power 9, as I got remainder 1, I can put it as 2 power 1, nothing but 2. If you don't know also, okay, suppose 2 power 9, 512, fine, we always have to experiment on the things which is known for you. 2 power 9 value 512, you know, 2 power 9 ending with 2. Now here, yeah, I am dividing that power with 4. Why you should divide power with 4? Cyclicity is 4 here. Cyclicity is nothing but 4, my dear friends. After 4 powers, same units place is repeating. Okay, so we have to divide power with 4, and shortcut in general, divisibility by 4 is last 2 digits only we have to check. 4 is 2 square, we need to check only last 2 digits for divisibility by 4. Divisible by 4 rule is only checking last 2 digits. Now power 2 power 9, okay, 9 is a single digit, no problem, but for this big numbers 1231, if you want to handle, take last 2 digits, 31 sir, divide with 4, 4 7s 28, we have 3 remainder, right. So we can mention this as 2 power 3, nothing but 8. 2 power 3, nothing but 8, my dear friends. Yes, what is the units place here is 2 power 1231. Power we should divide with 4. If remainder is 1, means we can write as 2 power 1. Remainder 2, 2 square. Remainder 3, 2 cube. But when you write 2 power 4, when you divide any number with 4, we don't get remainder 4. When a number is divided by 4, remainder is 0, 1, 2, 3. When you got remainder 1, you are writing as 2 power 1. Remainder 2, 2 square. Remainder 3, 2 cube. When you will write 2 power 4 is when remainder is 0. When remainder is 0, you are writing as 2 power 4. Okay, mark that point. Okay, and we will summarize in next example. See this question, my dear friends, previous question. Yeah, this concept we will summarize in the next example again. See here, 2 power 1000, this I think you understand, right? 432 power 1231, 2 power 1231, power should be divided by 4 because of cyclicity 4. We analyzed it, cyclicity is 4. Okay, as per divisibility rule, we have to check only last 2 digits for divisible by 4. We are taking only 31. Remainder is 3. So 2 power 3 is nothing but 8. That much simple we can do. Now see one previous year question, my dear friends, related to SSC CGL. Here they are asking units digit in the sum of first 111 whole numbers, 111 whole numbers, natural numbers, whole numbers. Natural number starts from 1, whole number starts from 0. Here problem is 111 whole numbers means it started from 0, 1, 2, 3, so on you have up to 110. Sum of this, it's nothing but we are calculating 1 to 120, 110, 1, 2, 3, up to 110 you are going to find, my dear friends. Okay, this is like n into n plus 1 divided by 2, 110 into 111 divided by 2, this is 55 into 111. So here, as we discussed, if you want to find the units place, here 5 into 1 ending with 5, answer must and should end with 5. So units place is nothing but 5, my dear friends. Lot of people, they didn't see the question properly, they will take it like a natural numbers, 1, 2, 3, so on up to 111. No, they given 111 whole numbers means you should start from 0 up to 110 only. Right now, sum of this means 0 is not counted for the summation anyhow. 1 to 110 you have to do summation. N into n plus 1 by 2, natural numbers, sum of natural numbers is n into n plus 1 divide by 2. Using that, n natural numbers 110, 110 into 111 divide by 2. If we just do, we got 55 into 111. Now here, units place 5 into 1, ending with 5, my dear friends. Answer should end with 5, see. Okay. Now my dear friends, if you want to discuss regarding units place for 4, see, we need to give the summary for that. We are done with only 2. Listen, my dear friends, 2, 3, 7, 8. Not only 2, 3, 7, 8 all having cyclicity 4. 2, 3, 7, 8 is having cyclicity 4. 0, 1, 5, 6 is having cyclicity 1. 0, 1, 5, 6 is having cyclicity 1. Whereas 4 and 9 is having cyclicity 2. I will explain you, okay, how you got cyclicity 1, 2, all those things going forward. So this is difficult for us to remember which is cyclicity 4, like cyclicity 2, cyclicity 1. Then what you can do if it is difficult, you can consider all numbers having cyclicity 4 only. See, when the number is repeating, okay, after every 4 powers, 1 power, okay, cyclicity 1 means it will also satisfy cyclicity 4. Cyclicity 2 also satisfy cyclicity 4. All can be, all numbers we can consider from 0 to 9, all numbers you can consider as cyclicity 4. Okay, you can divide any number power with 4, pick the remainder. If remainder is 0, substitute power as 4. For remaining 1, 2, 3, you can directly substitute in the power. Or else you should know 0, 1, 5, 6 is cyclicity 1, 4 and 9 cyclicity 2. How can you say 4 and 9 cyclicity 2, sir? See the 4, as this example also related to 4. See, sorry guys, 4 power 4 1 is 4. 4 square 16, units place is 6. My concern is all about units place, my dear friends. Our concern is only regarding units place. 4 cube 64, units place is 4. Now see, after 2 powers, 4 power 1 ending with 4, 4 cube also ending with 4. After 2 powers, we are getting same units place. Right, that's why this is having cyclicity 2. Okay, 4 power 4 is 256 ending with 6. Cyclicity 2 is there, you can understand here. Similarly for 9 also, 4 and 9 both have cyclicity 2. Now how can you handle now? If you understand this cyclicity, what is easy for you right now? 4 power odd number, 1 and 3 are odd number. 4 power odd number is definitely ending with 4, my dear friends. 4 power odd number, units place is 4. 4 power even number, units place is 6, my dear friends. See this, 4 square 16 ending with 6. 4 power 4 256 ending with 6. 4 power even number. See here, this question, first I can make it like, we can write it like 4 power 102, 4 power 103. 4 power even number ending with 6. 4 power odd number ending with 4. No need to divide power with 2 and all. Simple, even number, odd number. 4 power even number ending with 6, 4 power odd number ending with 4. So 6 plus 4, 10. Units place is nothing but 0. The question is only regarding units place. Units place is 0. Previous SSC CHSL paper this is, yeah fine, okay. 4 power even number, 4 power odd number, whether it is 294 or 194, no problem. We need only units place here. They are asking about units place. Got it? Now next question I will display, I will wait for your answers my dear friends. See this one, 2378 is having cyclicity 4, I already mentioned. Now let me check how many of you can answer this. Yeah, see this one my dear friends. What is the answer for this question? 192 to the power 102 and here 193 to the power 103. Answer my dear friends. Yes. If you just observe this one my dear friends, here units place is 2, 2 power 102, here units place is 3, 3 power 103, right. Cyclicity is 4, I already mentioned, okay, for 2378, not only 2378, for all numbers you can consider cyclicity is 4. Cyclicity 4 means divide last 2 digits with 4, here last 2 digits is 2, 2 cannot be divided with 4, so remainder is 2 only, 2 square. Here 3 also cyclicity 4, any number you can take cyclicity 4 also. Okay, if it is difficult for you to remember which is what cyclicity, you can just consider all are cyclicity 4. You will get the answer, same answer, no issue. Here, okay, 103, so last 2 digits is 3, when you divide by 4, we have 3 remainder, 2 square 4, 3 cube 27, 7 units place is 7, 11 my dear friends all together. So we can say 4 plus 7, 1 ending with 1. So 11 ending with 1, units place in 192 to the power 102, 193 to the power 103 is nothing but 1 my dear friends. We had to find units place here, we got 1. So this how to handle this type of questions. You can divide power. See the summary you just keep in mind, take the power, divide by 4, if remainder is 1 or 2 or 3, substitute that directly in the power. This summary you can apply for any number, not only for 2, 3, 7, 8, for all. If remainder is 0, substitute power equal to 4. If you do like this for any number, you will get same answer, no problem. Okay, instead of remembering that cyclicity 2 for few numbers, cyclicity 1 for few numbers, we can use this. Divide power, take the power, divide with 4, if remainder is 1 or 2 or 3, substitute directly in the power. If remainder is 0, consider power equal to 4 my dear friends. Got it? Superb. Now see the next question. Try this question my dear friends. Solve this one, find units place in this expression. Once this units place completed, we are already done with recurring decimal, converting into fraction, units place. Okay, factors are divisors, divisibility is also important for you. We have to move for that. Now see this one my dear friends, units place. Yeah, Naveen Kumar Varagani, Malisheti Naveen Kumar, Kashyap, good. Yeah, Bhavani, your answer is also correct. Your remaining, check this. Here, first what you have to note down, 3 power 144 and here 5 power 123, here 1 power 510, 6 power 25. See, with examples we are trying to give you inputs. See, already I mentioned 0156 is cyclicity 1. If you don't know, we can use cyclicity 4 concept. If you can recall, This is cyclicity 1. Why this is cyclicity 1 is, you can see 5 power 1 is 5. 5 square 25, my dear friends, ending with 5. 5 cube 125 ending with 5. All are ending with 5, right? So cyclicity 1. 6 power 1, 6. 6 square 36 ending with 6. 6 cube 216 ending with 6. See, this all are ending with 6. Cyclicity 1, my dear friends, cyclicity 1. Okay, after every 1 power the same unit space is repeating, cyclicity 1 here. Okay, now 5 power I can write directly 5. 1 power 1, 6 power this is 6. All these are already out. Now 3 power 144. Power we should divide with 4. Last 2 digits. 44. Here it is exactly divisible by 4. Okay, we have remainder 0. When remainder is 0, I recommended you to just go through. Yes, you take last 2 digits, divide by 4. 4 11s 44, so remainder 0. Few people will put 3 power 0. But guys, as a standard method, you consider this is 3 power 4. When remainder is 0, put power equal to 4. So 3 power 4, 81, units place is 1. That's it, my dear friends. You can go ahead, option A. Okay, so we are done with recurring decimal conversion into fraction, and we are done with this unit space concept. Take small break, my dear friends. After break, we'll go for few more concepts in this number system. Okay. Friends, so we are done with units place. We're done with units place. So let's go for the next one, my dear friends. Yeah, this question, units place, yeah, this one you can just try from your end. You have to get answer 3. See, one point in units place regarding factorial especially, n factorial ends with 0 if n value is greater than or equal to 5. N factorial units place is 0 when n is greater than or equal to 5. 5 factorial is 120, my dear friends. 6 factorial 720 ending with 0. Okay, 7 factorial 5040 ends with 0. You can observe that. Okay, 8 factorial is nothing but 40,320 end with 0. So all this are ending with 0. After 5 factorial or including 5 factorial, from 5 factorial onwards every factorial end with 0. So you can use the trick here to solve this question. We'll get units place 3, my dear friends. Okay, for this factorial model you can use this trick. Fine. Now see the next concept, my dear friends, reminders. Okay, let's focus on reminder. Yeah, here basic question, my dear friends, find reminder when 57 is divided by 11. Reminder, previously units place, now we are focusing on reminder. When 57 is divided by 11, what is the remainder, my dear friends? Remainder is nothing but equal to 2. So 11 5s are 55. Remainder is 2. I don't want about quotient also here. We want only remainder, dear. Okay, we got 2 as the remainder. Fine. Now, similarly, here many are doing some mistake. Remainder when 8 divided by 12. What is the answer here? Remainder when 8 divided by 12. Yes, what is the remainder, my dear friends? Post your answers. Remainder when 8 is divided by 12. Check this. Yeah, 8 divided by 12. Remainder is nothing but 8, my dear friends. See, numerator when it is less than denominator, we cannot divide. Lot of people doing mistake like, sir, for 2 times, for 3 times, 2 by 3. For 2 times, for 3 times is not correct. 8 divided by 12, okay, numerator is less than denominator. Directly we should write 8, my dear friends. Directly we should write 8. Don't divide 4 2s, 4 3s, 2 divided by 3, remainder is 2 is not correct. Okay. Now see the first example, my dear friends, to understand the reminders from basics. Okay. When 37, you read the questions, guys. So 37, 57, 78, 75, 179. When you are divided with 17, what is the remainder is the question. It's not like, see, this numbers product will be there, addition they may ask you, okay, they may give for big numbers as well. Start with the basics, my dear friends. See, 37, 57, 78, 75, 179 divided by 17. What is the remainder? 37 divided by 17, 17 2 times 34, 3 is the remainder. Remainder only we are mentioning here. Kindly note down, remainder only we are mentioning. 17 3s are 51, 6 is the remainder, my dear friends. 17 4 times 68, 10 is the remainder. Okay, 17 4 times 68, 7 is the remainder. 17 10 times 170, 9 is the remainder, my dear friends. This is all reminders. Okay, now again 10 plus 7, 17 will be cancelled. 17 is exactly divided by 17, right? 10 plus 7, 17. 17 is divided by 17. Why again waste of time, right? So here 9 plus 9, 18. When 18 is divided by 17, what is the remainder is nothing but equal to 1. This is the basic question, my dear friends, to understand the remainder. If you want to understand the reminders better, this is the basic question you have to know. Got it? So when 37, 57, 78, 75 and 179 is divided by 17, what is the remainder is 1. Okay. See the next question, my dear friends. Here 557, 653, 672 divided by 9, what is the remainder we have to find. Okay. See, for divisibility by 9, the shortcut is sum of digits. Instead of dividing the entire number, we can go with sum of digits. Same thing also here you can utilize. Divisible by 9, the rule is sum of digits we can consider. Here 557, sum of digits is 17. 5 plus 5 plus 7, 17. You can divide 17 with 9. Remainder is 8. 17 divided by 9. 9 once 9, 8 is the remainder. Got it? Whereas here 6 plus 5 plus 3, 14, my dear friends. When 14 is divided by our 14, 1 plus 4 is 5. Okay, instead of that also okay, fine. Here 17, 1 plus 7 is 8. 8 cannot be divided by 9. 8 we can write directly. Here 6 plus 5 plus 3, 14, 1 plus 4 is 5. 5 cannot be divided by 9, we can write 5 remainder directly. That's the logic with 9 actually advantage. 6 plus 7 plus 2, we got 15, 1 plus 5, 6. Okay, now here 8 into 5, 40, multiplied with 6, 240. 240 means again, save the time, sum of digits, 2 plus 4 plus 0 is 6. Here 6 is not divided by 9, so we got remainder 6. 6 divided by 9 means 6 numerator is less than denominator. Stop dividing, we can go with 6 here. Option D, my dear friends, 6. Sum of digits for 9 especially, we can use sum of digits concept. 17, 1 plus 7, 8. Adding all, okay, 14, 1 plus 4, 5. Adding all, we got 15, 1 plus 5, 6. Reminder is that you just check it out. Okay, when 557 is divided by 9 directly also, you got 8 remainder. Okay, you can use this trick, my dear friends. Okay, this is what individually when it is multiplication or maybe addition, you can apply this reminders concept. This is basic question. We'll go for the next level as well. See the next question, my dear friends, here. Now similar to previous one, okay, similar to previous question, but there we used the trick. Okay, 9 trick is there, but here we have to divide by 34, my dear friends. 75, 73, 78, 76, all this product we should divide by 34. Okay, here 34, no such tricks exist. Now we have to do directly. 34, 2 times 68, 7 remainder. 7 remainder. I am mentioning remainder only here. Don't think that is a quotient, it's remainder only. Now 34, 2 times 68, 5 remainder. We got 5 remainder here, my dear friends. Next one, 10 remainder, is it? We got here 10 remainder. Here 8 remainder, my dear friends. Now again 7 into 5, 35, 1 remainder for that. 10 into 8, okay, 80, divide by 34. Now see, 35 divided by 4, 1 remainder. 34, 2s are 68, you got 80, 68 means, okay, you have 12 remainder, 1 into 12, numerator less than denominator. So again don't cancel here, stop. Remainder is 12. When numerator is less than denominator, kindly stop it. Okay, so 12 divided by 34, we have to get 12, my dear friends. Got it? So option D. Fine. This is the basic question related to reminders. Slowly we can go for next level. Yeah, my dear friends, hope you understand this. Now see one example. Reminder when 9 power 250 is divided by 7. See this example, my dear friends, how to find remainder when 9 power 250 is divided by 7. Right. First what you should do when 9 power 250 is divided by 7, 9 divided by 7, remainder 2, right. 9 power 250 means 999 like that 250 times. This type of questions we can expect 999 so on 250 times divided by 7. When 9 is divided by 7, remainder is nothing but 2. I can put this as 2 power 250 now. Say 2 remainder in first one, 2 remainder in second one. Like that all numbers 2 to remainder will get 2 power 250 divided by 7, my dear friends. Divided by 7. Okay. Here, sir, 2 power 250, fine. 2 power 250 is a big number, we cannot proceed. Now what you should do, write 2 square. 2 square is 4, not divided by 7. 2 cube. Here we have to think, my dear friends, this reminders concept is pure application part. You cannot by heart anything. Okay, you should understand the question you have to solve. Now you should think about the question, sir, 2 power 250. 2 power 250 value we cannot find. But 2 power 250, when you want to divide by 7, yes, we should write this as 2 cube. 2 cube means 8. Okay, if you want to write this as 2 cube, why not 2 square? So 2 square is 4. 4 cannot be divided by 7. Okay, better you can write like a 2 cube. This is one method, I will give other method as well. 2 cube if you want to write, my dear friends, 2 power 250 directly we cannot write as 2 cube. Better we can split it like 2 into 2 power 249 divided by 7. Okay, 2 into 2 power 249 divided by 7. So why you split like that? I have a thought already. We had to mention this in terms of 2 cube. We already decided that, right? Now 2 into 2 cube power 83. 3 into 83 is 249 divided by 7. 8 divided by 7, remainder 1, my dear friends. Observe here, 8 divided by 7 will get remainder 1. Okay, 1 power 83 is nothing but 1 for us. So this is like 2 into 1 power 83, nothing but 2. So 2 cannot be divided by 7. The remainder is 2, my dear friends. See, this question ended with 2. Okay, it's not because of this 2. Okay, it depends on the question. If suppose power is 2 power 51, I will get here 2 square into this. 4 will get. It purely depends on the situation, my dear friends. Don't bahar the thing. What you have to do, see, when you struck somewhere, you try to reduce the power, increase this inner value, so that it should be divided by denominator. Okay, producing some remainder also fine. You can have to keep on doing like this. This is method 1 to solve this question. If this is okay, fine, or else we'll see the method 2 as well, my dear friends. And we have some practice questions also going forward. 9 power 250 divided by 7. 9 divided by 7 is 2. Directly I can write 2 power 250. 2 power 250 is a big number. We cannot divide with 7. So whether we have to try to write it as 2 square, 2 cube, 2 power 4. 2 square 4 not divided by 7 waste. 2 cube 8 is divided by 7. Okay, 2 power 4, like that we should think. Fine. So I have to write this as 2 cube something. So 250 is not 3 multiple. We should split this as 2 power 1 into 2 power 249. Now this is just 2 cube. Got it? Now see the shortcut other method, my dear friends. For the same question I can say method 2, 9 power 250 divide by 7. See the method 2, my dear friends. For the same question, method 2, there are n number of methods, not only these two. Okay, so we are discussing 2 methods here. There are multiple methods to go ahead. First, what you can do, 9 divided by 7, 9 power 1 in the sense, 9 power 1 divided by 7, remainder is 2. Okay, keep it. Then 9 square, like units place concept, here also we should analyze. 9 square, 9 square is 81, divide by 7, remainder is 4. This is using cyclicity concept. This is cyclicity concept. Okay, we have to see after how much time same remainder is repeating. Units place cyclicity different, remainder cyclicity different. We have to analyze numerator and denominator powers increasing when this same remainder will come. Okay, now 9 cube after this. 9 cube divide by 7. So 9 cube is 729. 9 cube is 729. Okay, so remainder will come 1. Or else if you have a doubt, 9 cube if you don't know also, put it like 9 square into 9. For 9 square, you know already remainder is nothing but 4. For 9, you know already remainder is 2. 4 into 2, 8. 8 divided by 7, remainder is 1. Remainder 1. Okay. Next 9 power 4 if you want to do, see this 9 power 4, my dear friends. 9 power 4 can be written as 9 cube into 9 divided by 7. For 9 cube, already remainder is 1. For 9, already remainder is 2. So now you got same remainder again. After how many powers? See, the same remainder is repeated. This is what cyclicity. After 3 powers, same remainder is getting. Here cyclicity is 3 for this question. For other questions, cyclicity again may change. Don't fix cyclicity 3 for all numbers. One number in denominator changing, or this numerator instead of 9, if you have 11, things will change. Don't fix this. For every question you should analyze. Okay, if it is 11 power 250 divided by 7, you may not get cyclicity 3, you may get some other cyclicity. Okay, so here cyclicity 3, how you decided, sir? See, remainder is 2. Here also I got remainder 2. Remainder 2 again I got, same remainder. When same remainder is obtained, stop there, we have cyclicity 3. So what is the advantage with cyclicity 3? When cyclicity is 3, we should divide power with 3. We should take the digits from power, divide with 3. Cyclicity 4 means power should be divided by 4. Now divide power with 3. If remainder is 1 or 2, directly substitute in the power. If remainder is 0, consider power equal to 3. Consider power equal to 3. See this concept, my dear friends, cyclicity 3. For this example, cyclicity is 3. Now, what is the power here? 250, right? So, 250 we should divide with 3. Okay, when 250 is divided by 3, okay, this is 83 times, we got 249, we will get one remainder. We got one remainder. So, you just change that remainder here, 9 power 1 divided by 7. When 9 divided by 7, remainder is 2. See, this method we got answer 2. This method also answer is 2. Method what it may vary. So, but see analysis how you should do here. Whereas in cyclicity, yeah, it's very simple. For any numerator and any denominator, take that numerator first to power 1, divide by denominator, what is the remainder? Next, increase the power slow on, going on. Okay, where you have to stop is when same remainder repeat. Some question cyclicity 7 also there. Okay, some question cyclicity 3, 4, 5, it depends. If cyclicity is 7, divide power with 7. If remainder is 0, power as 7. For remaining cases, directly substitute in the power. Got it? So, many methods, my dear friends, we are discussing few for you, okay, to solve the questions, right? Now, see this question. This is a basic question actually, okay, no need of that much input for this. CGL previous year question. 7 divided a positive integer n, the remainder is 2. See, when n number is divided by 7, we got remainder 2. Meaning, n may be 2. 2 cannot be divided by 7, right? N may be 2. N may be 9 also. Okay. Or else we can consider n may be 2 or 9, your choice. When 9 divided by 7, remainder is 2. When 2 divided by 7 also remainder is 2. Okay. N may be 2 or 9. Now what they are asking, which of the following numbers gives remainder 0 when divided by 7? When it is divided by 7, it should give remainder 0. So, n plus 5, n is 2 or 9. Plus 5 means this is giving 7 or 14. Yes, 7 or 14 when it is divided by 7 gives remainder 0. If it is 7 or 14, then only when you divide by 7, remainder is 0. What about this, sir? N plus 2. N plus 2 means it may be 4 or it may be 11. It is not giving remainder 0. It's not correct. Remaining all options not correct. N plus 5. Previous CGL question, my dear friends. Okay. What should be? Okay. This number, n is already we decided. It may be 2, it may be 9, it may be, okay, we can go ahead with 19, no, right? 23 also, yeah, we can go with 23 as well. We can go with 16 also. N may be 16 also. 16 divided by 7, remainder 2. There are many possibilities for n. You take one among that and check which option is satisfied. Clear? Yeah, we discussed regarding factorial in units place. That will again help you here. You have to divide by 12. 1 factorial, 2 factorial, 3 factorial, 4 factorial, so on, up to 100 factorial. When it is divided by 12, what is the answer? 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, so on. When it's up to 100 factorial, divide by 12. What is the remainder, my dear friends? Okay, this is in terms of factorial. Okay, when it is divided by 12, we should find what is the remainder here. Now, say this one, my dear friends. 4 factorial is 24. From 4 factorial onwards, every number is divided by 12. All these are divided by 12. 4 factorial is 24, which is divided by 12. Remainder is 0. 5 factorial 120, remainder 0, when divide by 12, you are dividing by 12, right? So from 4 factorial onwards, okay, n factorial is divisible by 12, when n is greater than or equal to 4. Yeah, from 4 factorial onwards, every number is divisible by 12 actually. 4 into 3 required. 4 factorial is having 4 into 3, 12. Okay, 4 into 3 into 2 into 1, 4 into 3 is there. 5 factorial automatically have 4 into 3. Okay, so from there onwards, every number is having 4 into 3, 12. It's divisible. But up to here, 1 factorial is 1, 2 factorial 2, 3 factorial 6, my dear friends. See, 9 cannot be divided by 12. Remainder is 9. Don't divide with 3. That's not correct. Okay, we should take 9 divided by 12. Yes, remainder is 9, my dear friends. Clear? Okay. Ruchi Kashyap, good. Aditya. Fine. So see the next question, my dear friends. Excellent. See the next one. Now, here you are going to understand negative remainder concept as well. Negative remainder is also there, that you can understand with this example, my dear friends. See, here they are asking remainder when 10 power 6 minus 12 is divided by 9. Okay, 10 divided by 9, remainder is 1. 10 divided by 9, remainder is 1. So 1 power 6. 12 divided by 9, remainder is 3. Sir, 1 minus 3, we got negative. Yes, see, minus 2 means, so guys, minus 2 divided by 9 means 2 short of denominator. When you got negative remainder, how to convert into positive is 2 short of denominator, means answer is 7. Answer is 7, my dear friends. When you got negative remainder, minus 2 means, okay, 2 short of 9. Minus 2 divided by 8 means 2 short of 8, remainder must be 6. Minus 2 divided by 11 means 2 short of 11, okay, answer should be 9. Okay, when you have negative, this is how you should convert. Fine, 7, my dear friends. Got it? So negative remainder related, how to convert into positive remainder, this is how you should do. Okay, reminders, my dear friends. Yeah, one more question related to reminders, then we'll switch for the other concept, my dear friends. 127 power 97 plus 97 power 97, 97 power 97 divided by 32. Okay. Now see this, my dear friends. See, there are some rules like x power n plus y power n divided by x plus y. All those, instead of all that, very basic thing. When 97 divided by 32, when 97 is divided by 32, 32 3 times, 96 1 remainder, right? Okay, I can put it like 1. When 97 divided by 32, we have 1 remainder, 1 power 97. Okay. Whereas here, 127 divided by 32, see, 32 4 times. So guys, listen, 32 4 times, you see this advantage now using negative reminders. 32 4 times 128. Here you have 127. I can write minus 1 reminder, negative reminder. This is one shot. 127 power 97 can be written as 128 minus 1 to the power 97. As 128 is divided by 32, I will get minus 1 power 97. The idea behind that is this. 127 power 97 can be written as 128 minus 1. 128 divided by 32 exactly, remainder it will become 0, we will get minus 1 whole power 97. So numerator is now minus 1 plus 1 means 0. Okay, so yes, remainder 0. So this question, my dear friends, we have to get remainder 0. See this, negative remainder, cyclicity, yeah, you can solve with the cyclicity concept also. Positive remainder, now you understand negative remainder. Negative remainder also we can use. Fine. Okay, hope you understand this reminders, my dear friends. So units place, reminders concept done. Okay, converting that recurring decimal into fractions completed. Now factors are divisors. See, my dear friends, for some number, let's consider a number 24. What are the factors for the 24? For number 24, what are the factors means? 1, 2, 3, 4, 6, 8. These are all the factors, right? Okay, which numbers will divide that 24? Is nothing but 12 and 24. See, they'll ask in exam how many number of factors for the given number. What is the number of factors they'll ask you? So number of factors, if you list out here, we got 8 for 24, my dear friends. For 24, number of factors is 8. But in exam, okay, in previous SSC CGL as well, they given 3600. For that big number, if you want to list like this, it will take more time. So we need an alternate method. What you should do, what are the number they given, we should write it like prime number power. What are the number they given, my dear friends? You write it like prime number power. Here A, B, C are nothing but prime numbers. Okay, we should write this as prime numbers power. A, B, C must be A, B, C, not only A, B, C, there is some other prime numbers also involved, not only 3. Okay, it may involve more prime numbers as well. A, B, C are prime numbers. Now, number of factors. When you write given number as prime number power, number of factors or divisors how to handle is nothing but add 1 to the power, my dear friends. After writing this, add 1 to the power and then multiply. This is the shortcut, okay, otherwise it will take more time for you to solve the question, my dear friends. So we should add 1 to the power and then multiply to find number of factors. Okay, and number of prime factors, if you want to find number of prime factors, because these are the only two things, okay, they are generally asked in previous papers. Here there are even factors, odd factors, number of even factors, number of odd factors, number of perfect square factors, perfect cube factors. You can go sum of factors, product of factors, lot are there. But as per your exam concern, most which area they are focusing is number of prime factors and number of factors, my dear friends. Okay, number of factors, number of prime factors, this is how you should do. We can cross check in the previous whether the number of factors is it correct or not. See, for the number 24, writing is a prime number power, it is 2 cube into 3 power 1, 8 into 3, 24 is 8 into 3, 2 cube into 3 power 1. So here, if you want to find number of factors using that method, after writing given number as prime number power, what you should do? Add 1 to the power and then multiply, my dear friends. Now you got 4 into 2, which is nothing but equal to 8. Okay, you got number of factors 8. So you just try when I want to understand the things better. Okay, we have to try with the small numbers. Okay. Now go ahead with the question, my dear friends. See, the previous question, what they given total number of positive factors for 72 is 12. For 72, how many factors is there? 72, my dear friends, we can write this as 2 cube into 3 square, 8 into 9. We should write given number as prime number power. Okay, 72 as 8 into 9 we know, 8 is 2 cube, this is prime number. Now how to find number of factors? All these are positive only, right? Number of factors is nothing but add 1 to the power 4, here add 1 to the power 3, 4 into 3 is nothing but 12. Yes, number of factors 12 for 72 is correct. First statement is correct. Okay. Next one, sum of first 20 odd numbers. See, is 400 correct? See guys, actually sum of odd numbers 1 and 3, if we stop up to 1 and 3, 1 means okay, 1 itself 1 square. 2 numbers, 2 odd numbers, 1 plus 3, 4, 2 square. 1 and 3, 4, 2 square. If you go for next odd number, up to here 9, 3 square, 3 terms 3 square, 4 terms 4 square up to here. So on, up to 20 terms means definitely that is 20 square. 400. Sum of first 20 odd terms is definitely 400, my dear friends. Sum of first 20 odd terms. They clearly mention first 20 odd numbers is 400. Yes, you stop up to 4, add all this, we will get 4 square, 16. Then you add 9, you got up to 25, okay, 5 square. 5 terms 5 squares, 20 terms 20 square. Yes, correct, my dear friends. Next, the largest 2-digit prime number is 97. Okay, 99 is the largest 2-digit number. It's not a prime number. 98 no. 97, yes, 97 is the largest 2-digit prime number. All are true here. So guys, all are true. Fine. So you have to know how to find the prime number in the basic definitions. We didn't cover that. Fine, no issue. I hope you know 97 is a prime number. In upcoming sessions we will discuss how to decide given number is prime number or not also, no issue with that. Now 3600, okay, how to find the number of factors, my dear friends. 3600 is there, we have to calculate number of factors. So 3600, you should write given number as prime number power. First I am speeding, this is 36 into 100, not prime numbers this is. 36 can be written as 4 into 9, 100 as 4 into 25, 36 as 4 into, I split into numbers, okay, until it become prime number power like that. So this is 4 into 9, then 4 into 25, okay, this is 16, 2 power 4, 9, 3 square, 25 as 5 square, my dear friends. See, all these are prime number power, 2 power 4, 3 square, 5 square, all these are prime number power. Now, how to find number of factors is, add 1 to the power number of factors. Already 4 is there. So, 5 into 3 into 3, my dear friends. Hope you got 45. Okay, option A, my dear friends, number of prime they are asking factors, not prime factors. Prime factors is next example. Prime factor means very easy, 4 plus 2 plus 2, add that powers, number of prime factors. But here number of factors, my dear friends, when you solve, hope you got 45, clear. Now see the next one, my dear friends. See, don't worry about notes, notes is anyhow we are attaching to the YouTube link, okay, you just understand the concept, focus on the concept here. Now number of prime factors. You have to calculate number of prime factors for 30 power 5, 24 power 5. See, don't add 5 plus 5, 10, sir. You said, okay, add the power. But first it must be prime number power, right? So 30 is not prime number, 24 is not prime number. So what you can do, this is 5 power 5 into 6 power 5. This is 4 power 5 into 6 power 5. Okay, 5 power 5, 6 power 5, 6 power 5, 6 power 10. Among 6 power 10, you have 2 power 10 and 3 power 10. 6 power 10, 6 means 2 into 3, 2 power 10, 3 power 10. Here 4 power 5 is there, that is again 2 power 10. Don't write 2 separately, we should club at the end. Before deciding, we should club all at one side. 5 power 5, 2 power 20, 3 power 10. Adding all the powers, my dear friends, will get prime factors. 20 plus 10 plus 5, number of prime factors is nothing but 35, my dear friends. If you want to find number of prime factors, add all the powers. After writing given number as prime number power, add all the powers, my dear friends, to find the prime factors. Got it? Now, divisibility related. Okay, we'll discuss divisibility along with the examples, my dear friends. See, in divisibility, important is, yes, divisibility by 3 and 9, both the rule is you have to go with sum of digits. If sum of digits is divided by 3 or 9, then the entire number is divided by 3 or 9. We have examples related to that, no issue. Whereas 4 is nothing but 2 square, so we should check last 2 digits. For any number, check last 2 digits to decide whether the given number is divided by 4 or not. Similarly, for 8 is 2 cube, my dear friends, we should check last 3 digits. We should check last 3 digits. Whereas 16, if you want to go ahead, last 4 digits we have to decide. Last 3 digits for 8, whereas for 16, similarly if you just proceed, we have to check last 4 digits, my dear friends, as 16 is 2 power 4. Divisibility for 3 and 9 important, 4, 8 important, 16 not much important, but still you just know 3, 9, 4 and 8. Next one of the important is 11 divisibility. How to decide given number is divided by 11 or not. So guys, if suppose we have a number which is in terms of A, B, C, D, E, F, G. Okay, is this divided by 11 or not? If you want to decide this is divided by 11 or not, you take alternate A, C, E, G, B, D, F. A, C, E, G, B, D, F. So take this summation A, C, E, G, take the summation B, D, F. This difference, okay, A, C, E, G, B, D, F, this difference should be 0, or this difference should be plus or minus 11, or this difference, I can say simply, this difference should be divided by 11. Okay, this difference should be divided by 11. Very important is 11, 3, 9, 4, 8. Okay, this is very important for your exam concern. Divisible by 11 is this alternate numbers A, C, E, G, take the summation, B, D, F summation. These differences should be like 0, plus or minus 1, plus or minus 22 is okay, or the difference should be divided by 11. Right. Now, important thing, if you want to decide a number is divided by 12 or not, or if you want to decide a number is divided by 72, or if you want to decide a number is divided by 88, these all are previous year questions. I'll give one simple point here, then we'll move for the questions, my dear friends. See, divide by 12, don't take 2 and 6 combination. Whatever the number we have, you should write it like prime number power. 12 in terms of prime number, 3 power 1 into 2 square means I should take 3 and 4 combination, not 2 and 6. 2 and 6 is wrong for divisible by 12. So if a number is divided by 3 and if a number is divided by 4, then only the number is divided by 12. Don't go for 2 and 6, that's wrong approach. And similarly, 72 is 8 and 9, my dear friends. Okay, it's like 2 cube into 3 square, 8 and 9 only we have to go. Right, given number as prime number power. Okay, that combination here is 8 and 9. So I should see 72 means the number should be divided by 8 and 9. If it is divided by 8 and 9, then only it's divided by 72. Similarly, 88, my dear friends, 88 as, yeah, you know, 2 cube into 11, right. So 8 and 11 combination. 88 should be, the number is divided by 8, divide by 11, then only you have to decide the number is divided by 88. So guys, don't take it for 2 and 44 like that. Okay, so you should always check for 8 and 11 only if you want to decide the given number is divisible by 88 or not. Okay, so 3, 9, okay, 4, 8 and that 11 and this combinations, which combination you have to prefer is important. Okay, now see the first question, my dear friends, divided by 9, divisible by 9. For divisible by 9, what you require? Sum of digits. What is sum of this? See, if you want to save the time, here 9 is divided by 9, waste of time, you can call, no need to add. 7 plus 2 is 9, that also you can remove. I can say sum of this is 14 plus x. No sir, I'll take those two also. Fine, okay, you will get still 18 extra, means 32 plus x. That will not disturb my logic actually. 32 plus x or 14 plus x. This should be divided by 9 means x must be equal to 4. X must be equal to 4. Okay, sir, 4 is there in the options, but previous question, see, they are asking 2x, my dear friends. 2x. What is 2x is nothing but equal to 8. So, read the question properly what they are asking. X value 4, I agree, you are good in concept, but what they are asking at the end, sometimes they will ask x by 2, x square, 2x. So, here they are asking 2x, my dear friends. Divisible by 9. So, in this number systems, as I mentioned in the introduction, recurring decimal to fractions, units place concept, okay, and reminders concept, divisors or factors, divisibility. These 5 are very important, that is why we are covering those 5 concepts in number system. Okay. So, the next one, my dear friends, now divided by 4, the largest number for that star or a, something you put it like a for your better understanding, or something like x, this should be divided by 4. Divisible by 4 means last 2 digits we have to check. So, what should be the largest value of x divided by 4? See, 24 divided by 4, 34 no, 44 divided by 4, 54 no, 64 divided by 4, 74 not divided, 84 is divided by 4. 84 is divided by 4. Largest value of x is 8. What is the largest value of x we can consider is 8. If we take x value 9, 94 is not divided. For divisibility by 4, this is divisible by 4. We should check last 2 digits only. Don't take this big number, 2,36,000, not required. Tens place and units place, that's sufficient. Last 2 digits is sufficient. Clear? Now see the next question, my dear friends, divisible by 8. Divisible by 8. For divisible by 8, okay, let us consider that is something y. Divisible by 8, last 3 digits we have to focus. Last 3 digits. The greatest value of y maximum they are asking. What should be the maximum value of y? Okay, this is, yes, we have to divide this last 3 digits. Fine, you can use from maximum to minimum 9. If I put 9 here, is 948 divided by 8? Sir, 11 times 88, sir. 11 times 88, still 6 remainder 68, not divisible, sir. Okay, waste. Then take, okay, 9 is eliminated, then go with 8. If I take 8 here, 848 is divided by 8, yes, 106 times, like 10 times 80, 48 is divided by 8 6 times, so 106 times. Yes, y maximum value is nothing but 8. You can take y value 8, okay, last 3 digits we have to check. Divisible by 8 is last 3 digits, divisible by 4, last 2 digits. This is all previous year questions only. Fine. Now up to that, fine. Now divisible by 11, my dear friends. Okay, 4, 9, 8, now 11. Divisible by 11. For divisible by 11, what we given? Alternate numbers means 4 plus 3 is 7, 7 plus 3 10, 10 plus 8 18 minus remaining 6 plus 9 15, 15 plus x. This difference, okay, if it is 0 or 11 like that or minus 11 also fine. If x is 3, this becomes 0, it is divided. X is 3, okay, no problem. So, we can take x value 3 here. 18 minus 18, nothing but 0. So, we can take x value 3. So, it is divisible by 11, my dear friends. If you want to check divisible by 11, we can take x value 3. 18 minus 18, nothing but 0. Got it? So, this question, my dear friends, is alternates. Okay, there is other possibility for x also, but x is the digit. Don't take, sir, x value, I will take it as 14, sir. 14, 18 minus 29 minus 11. X is a digit. It is a tens place. It should be a digit, single digit we have to take. Don't take it as 2 digit number. Fine. 11, okay, 12. For divisible by 12, my dear friends, 2 more questions we can wind up, okay, today's session. So let's divide by 12, my dear friends. For divisible by 12, we should check 3 and 4. Okay. For 4, Last two digits, last two digits are divided by 4. Yes, no problem. 24 divide by 4, no issue. For divisible by 3, what you should check? Sum of digits. What is sum of digits here? 12 is 13, 13 plus 9, 22. 22 plus x must be divided by 3. They are asking minimum value of x or least. Yes, least value of x must be 2. X must be equal to 2. Then only 24 least value. X may be 2 or 5 or 8 also. 8 also okay. 22 plus 8, 30 divided by 3. X value 8 also okay, my dear friends. But they are asking minimum. Least value they are asking. Minimum value, so we should go with x value 2. Got it? So 12, fine, 11. Now 72, my dear friends, 88. There is a question related to 72 and 88 also. We discussed already. To decide 72, we should go with 8 and 9. For 8, last 3 digits 7, 8, y. 7, 8, y is divided by 8 means, see 8 9s are 72. Remainder is 6 here. 6 something divided by 8 means 64. Y must be equal to 4. Y must be equal to 4. Divisible by 8 means y must be equal to 4. Then only this is okay for us. Right. Next, y value 4 fixed. Next, divisible by 9. Divisible by 9 is sum of digits, right? So x here 3x 7 8 4. Now divisible by 9, sum of digits. Sir, here we have 9. I already mentioned 9 means directly we can ignore also actually. Okay, I can do like this also. See, to save the timing, what you can do in exam, 9 is waste. 3 plus 6, 9. 9 is divided by 9. Why you have to check that? Okay, 8 plus 5, 13. Okay, 7, 20, 28. And 4, 32. 32 plus x should be divided by 4 means x must be equal to, divide by 9, this should be divided by 9 means x must be equal to 4. 32 plus x should be divided by 9 means x must be equal to 4. Check once. Yeah, I will take entire values also. 17, 22, 31, 38, 46, 50. Yes, 50 plus x should be divided by 4 means x should be taken as 4. Fine. X value 4, y value 4 both. So this is 4 into 4 minus 3 into 4. Both x and y both are equal. So we got x nothing but 4 only. You can take x and y both equal. Okay, you can just substitute. 16 minus 12, we got 4, my dear friends. So guys, last question for today's session related to divisibility. We discussed a lot of questions today from previous papers. Okay. So this last question, divided by 88, my dear friends. Divide by 88, rule is 8 and 11. For 8, last three digits we have to focus. 901y should be divided by 8. 8 11s 88. We got 3 remainder. 3 something should be divided by 8 means y must be equal to 2. Then only it's divided by 8. 9 12 is divided by 8. Then let's come for x value, my dear friends. Here 179 x 0 9 1 2. This should be divided by 11. For 11, what is our concept? Alternate digit summation, right? So guys, see this. 1 plus 9 10, 11, that is 11 here, minus remaining numbers 7 9 12. So this is 18 plus x. Okay, this difference may be 0. Okay, 0 not possible now. It may be plus 11 minus 11 also. Minus 11 possible. If this is 4, we got minus 22. X can be taken as 4. If x is 4, we will get minus 11 finally. Yes, divide by 11. Minus 11 plus 11, 0 is also okay. 0 plus or minus 11 plus or minus 22, like that. Again, x value 4, y value 2. They are asking, my dear friends, 5x minus 8y. So guys, 5x minus 8y. X value 4, 20. Y value 2, 16. So hope you got 4. Fine. So guys, this is about the divisibility. Okay, so we discussed around 5 to 6 questions in divisibility. So hope you understand this entire concepts, my dear friends. So keep in mind, which is very important as per your previous year papers, all these concepts you have to just recall. So yes, we are done with divisibility, okay, which is important for the number of factors or divisors, reminders, units, place or last digit, recurring decimal to fraction. Remaining concepts is also there. Highest power or factor, also few questions they already asked, okay, but important as per SSC CGL concern, as per previous year papers discussion is this 5 concepts, my dear friends. Okay, fine. Thank you so much for attending the session, guys. Take care. And make sure tomorrow also we have session daily, okay, as a preparation league for your SSC CGL preparation. Daily we have sessions. Make sure you will be available at 7 o'clock to attend this free webinars.